Now, starting off with question 7, which is an electricity question, they said the circuit diagram below consists of 4 cells. Now, each has a voltage of 1,5. Now, if I were to circle my cells, this would be the first, second, third, and my fourth cell. Now, each has a voltage of 1,5. Now, the resistance, so they gave us R. I need to make note of these values on my diagram, right? So let me just erase those circles there at the top. So now they're telling me that, okay, the resistance of bulbs A, B, and C. So starting off at A, they say it's 3. Now, B, it's 6. And C, it's 8. Now, use the circuit to answer this question. Now, they tell us that when this switch is closed, the ammeter reading here, it will be 0.6 A. Now remember, what does this ammeter here represent? It represents your total current, or the reading here, this is your total current. Because why? This ammeter reading is separate from other resistors, and it's also closer to your battery. So this represents your total current, which is 0.6. Now, the first question, they want you to define what is EMF, right? Now, simple explanation of your EMF. EMF is work done per unit charge by the battery. Done. Remember, EMF and voltage, they are more or less the same thing. Work done per unit charge by the battery. Now, 7.2, they say write down the EMF of the battery. Now, if each cell is 1.5 volts and we have 4 cells, so multiplying 1.5 times 4, my total voltage or my EMF of the battery should be equals to 6 volts. Now, 7.3, they're telling us that the reading on V3, right, it's 4.8. So this is V3. This is 4.8 volts. And now if this is 4.8 volts, we need to calculate the effective resistance of the circuit. Now, how would we go about doing that? Now, what is your effective resistance? Effective resistance, simply in other words, it's your total resistance. So 7.3, 7.3.1, we need to calculate your total resistance. Now, remember, how do you go about calculating your total resistance? So it will be your resistors, so RT, it will be your resistors connected in parallel added to your resistors connected in series. Now, first, let me classify which resistors are connected in parallel as well as which resistors are connected in series. Now, starting off with A and B, they are connected in parallel with one another. Now, because your C is not parallel to anything, right? As you could see, it's alone the light bulb. It doesn't have another light bulb which is at the top or bottom of it. So as a result, my light bulb C, it will be connected in series. Then I'm saying that my effective resistance, which is my R2, to find it, I need to find my R parallel and add it to my R series. Now, I know that, okay, what is the total of my resistors connected in series? I only have one resistor which is connected in series, and this is 8. So I know that my R series is 8. Now I need to calculate my R parallel. Now, how would I go about calculating my R parallel? I'm going to make use of, remember, how do you calculate resistance when resistors are connected in parallel? You need to make use of this formula, 1 over RP, which is your parallel. It is equals to 1 over R1, depending on how many resistors you have. Here I have 2, so it will be 1 over R1 divided by 1 over R2. Now, my R1, my resistor 1, which is, I could make it resistor A, it's 3, so 1 over 3. So 1 over RP is equals to 1 over 3 plus my resistor 2, which is 6. And now adding these 1 over 3 plus 1 over 6, punching it into your calculator, you should get resistance of 1 over 2. So 1 over RP basically to be equals to 1 over 2. And from there, you can take this up. Same as this, you can take this up so that your RP would be equals to 2. So your R parallel is 2, meaning that your RT, which is your effective resistance, would be equals to 10 ohms. Now, what if we had a scenario like this? Let's say this is a light bulb, right? Because this year, in terms of light bulbs, we had 2 light bulbs. These are in parallel with one another, and then we have this which is in series, and this is 2 ohms, for example. Now, let's say that this is 3 ohms, this is 4 ohms, this is 6 ohms. Now, in a scenario like this, we know that these are connected in parallel. And this, because it's not in parallel with anything, it will be connected in series. How would we calculate our R total? Same approach. R total, it would be R parallel plus my R, which is in series. Now my R series, I know that here I have only one resistor in series, so this is going to be 2. What about my R parallel? I have 3 resistors in parallel, so 1 over Rp, it will be equals to, so first I'm going to start with this because it's alone, 1 over 6 plus 1 over, because these two, they are parallel to that, and as a result, they are also in series with one another. This would be 1 over 3 plus 4, right? As a result, our 1 over Rp to be equals to 1 over 6 added to 1 over 7, which should be equals to 42, or 13 over 42 rather, 1 over Rp. So as a result, your Rp would be equals to 42 over 13, right? Now punching that into my calculator, 42 over 13 is the same as 3.23 ohms, rounding it off. So this is how we would have done these calculations if maybe you had another light bulb, which is next to this light bulb A, or next to this light bulb B. Now, let me calculate the reading on V2. Now, how many voltmeters do you have? So can you see you have V1? Now V1, because it's connected to your battery, this would represent your total voltage. Now to get this total voltage, this would be the addition of V2 plus your V3, right? And as a result, I know that my V1, which is my total voltage, or my EMF, which I've calculated before, is 6, and my V2, it's what I'm looking for. My V3, I was told that it's 4.8 volts. So as a result, my V2, it will be equals to 6, subtract 4.8, which would be equals to 1.2 volts. Now, answering the preceding questions, amount of charge that is passing through resistor C in 20 seconds. Now, when you are asked to calculate charge and you are given time, you should make sure that the formula which you're going to choose, remember charge is your Q. The formula that you're going to choose is going to have whatever that you're given. So here I'm told that I need to calculate the amount of charge passing through my resistor C, right? At my resistor C, what is it that I know? I know that my resistance there, my R, it is equals to 8 ohms. I have the voltage there, which is equals to 4.8. Now, they also gave me time as 20 seconds. So now, meaning that the formula that I'm going to use here, right, it should have most of the information that is here, but then most importantly, it should have T, because you're given time. And the appropriate formula that you're going to use is Q is equals to I multiplied by your delta T, which you are given. Now, what is I? I is your total current. Or this is your current, by the way. Let me put it that way. Not total current. This is your current. Now, if the voltmeter reading here is 0.6, I mean, if the ammeter reading here is 0.6, what would be the ammeter reading on this resistor here? The ammeter reading would be also 0.6. Why? It is because this resistor is connected in series. And remember, what do we know about series circuits or series resistors? We know that in a series connection, your current is constant, meaning that current is the same. So because here current is 0.6 and here, because it's this resistor is connected in series, the current here would also be 0.6. Remember, current in a series connection, it's constant. But the current here, because this is a parallel connection, it won't be the same as the current there, right? So I know that the current there, it's 0.6, and I'm given time as 20 seconds. Now, multiplying these two values, your charge should be equals to 12 coulombs. Now, the last questions would always be Ohm's law formulas, whereby you would need to answer them, making use of this Ohm's law formula to remember it. R is equals to V over I. So here they say if light diffuses, meaning that when we eliminate light bulb. Now, how would this affect the total current? Now, always you need to expect this in terms of Ohm's law, even though they're asking you about current, but before, every time you're going to start with explaining what happens to resistance, and after you're going to go to current. Now, in accordance to this formula here, right, resistance is directly proportional to voltage, meaning that if R increases, your voltage would also increase. Same applies with if R decreases, your voltage would also decrease. Now, also, your resistance is inversely proportional to your current. So if resistance increases, your current would decrease. Similarly, if your resistance decreases, your current would increase. So now, first let's ask yourself, if B is removed, what would happen to the total current? First, you need to ask yourself, that resistor that they are removing, was it connected in series or in parallel? Remember, we said this connection right over here, it would be a parallel connection. Now, what happens when you remove a resistor connected in parallel? So let me just So when you remove a resistor connected in parallel, this increases the total resistance, right? So when you remove a resistor, your total resistance would increase. But when you add a resistor in parallel, what would happen to your total resistance? Your total resistance would decrease. But in a series connection, when you remove a resistor, resistance decrease. When you add a resistor, resistance increases. So your series connections work in a normal way. So first you ask yourself, that resistor you're removing, is it connected in parallel or in series, right? Now you know that it's connected in parallel. And what did we say? When you remove a resistor connected in parallel, what would happen to your total resistance? So your total resistance would increase. Now, as a result of your total resistance increases, what would happen to your total current, which is what the question is asking us? Would it increase, decrease, or remain the same? In this case, you would see that your current would decrease. Resistance increases, current would decrease. So here we say, okay, current would decrease. And our reason would say, okay, the reason being is that the total resistance, remember, when we remove that resistor, the total resistance will increase. And you would state, and because resistance is inversely proportional to current, meaning that if one increases, the other one decreases. Therefore, your current will decrease as a result. All right. And this will be all for this question. Now, in the next video, we're going to be looking into the last question, which is your question 8.